Assalamu alaikum. Today I will follow the guided lab 3.5 machine learning pipeline with Amazon SageMaker. So in this lab you will deploy a trained model and perform a prediction against the model. You will then delete the endpoint and from a batch transform on the test dataset. Note the model is constructed when you in the notebook as part of the setup. Okay, our objective is to deploy a machine learning model and use the dataset to perform a batch transform with the model. Okay, and I have already opened the Jupyter notebook in here. So okay, in this lab 3.5 we have in the overview section, and we are now continue the vertebral column dataset. In the module 3 we have we have trained a machine learning model previously. So let's start one by one. In the overview, this lab is a continuation of the guided lab in module 3. In this lab you will deploy a trained model and perform a prediction against the model. You will then delete the endpoint and perform a batch transform on the test dataset. So, introduction to business scenario. You work for a healthcare provider and want to improve the detection of abnormalities in orthopedic patients. You are asked with solving this problem by using machine learning. You have access to dataset that contains 6 biomechanical features and a target of normal or abnormal. You can use this dataset to train an ML model to predict if a patient will have abnormality. About this dataset, this biomedical dataset was built by Dr. Hunter Q and etc. And we have 3 categories: normal, dyschondria, and spondylolisthesis. And these 2 are actually abnormal cases and normal cases we have 6 attributes and 6 biomechanical attributes in here. So, and we have following classes: dyschondria, spondylolisthesis, normal and abnormal, and dataset attributions and lab setup. Because this solution is split across several labs in the module, you run following cells so you can load the data, train the model to be deployed. So, well, since we have seen the details of the dataset before in the 3rd module, I skipped them fast. So let's start by importing the data. By running the following cells, the data will be imported and ready for use. The following cells represent the key steps in previous labs. So we are now defined a bucket ID in here, and we are importing the necessary libraries. and we are downloading our dataset in here and download and extracting the zip file, and yes, we have our data in here. We have downloaded it, and after that let's see the data frame. In here you can see the data frame, imported data, and we will as you can see in the class, we have abnormal and normal cases. We will use a simple mapper to map these features. Let's run it. I want to add another yes, as you can see, we have successfully transformed the classes into binary classification using a simple mapper. And after that we need to move the target variable, the class is our target, into the first column. So because the machine learning model needs the target to be placed in the first column, so let's also use df.head to see the results. Yes, as you can see, we have moved the class in the first column. So we need to split our data. We have test sizes 0.2, which means the 20% of the data will be used in the test and validate in here, and 80% will be used in the training. So the in here what's important is stratify is this makes the distribution uniform between test and training and testing data we have split, so that it has similar effects on both training and testing. We can see, let's also run this. We have split our data in prefix. Yeah, well, in this cell, we are uploading our training, testing and validate data sets into S3 buckets. So let's run it, and I want to check if I have access to S3 instances, bucket instances. Yes, I want to go to US East 1, and yeah, let's go to buckets maybe. Well, I don't have permission to list buckets. Okay, so we need to retrieve an XGBoost container image. So let's search it in Google what options we have. shall be. So yes, in the Docker registry paths and example code section for the documentation in the Amazon SageMaker ECR paths, we need to go to US East North Virginia, and we have XGBoost algorithm in here. So we can see that our version is 1.01, which is, I guess, these are, as you can see, first we will train our model, so we shall using this registry path, and so let's continue. The container we have is we will use XGBoost. This is our session name, sessions region name we are using, US East 1. And our model version is 1.01. So we have our hyperparameters in here. So S3 output location is here. This is where the trained model will be outputted. So the estimator will then run to estimate the values in here. The training channel is in here, as you can see, the validate channel as well, data channels, and XGBoost model. We will then fit our model to our data channels, and we will not log anything in here. Let's run it. Let's see our jobs in here. Processing, no, training, I guess. Training jobs. Yes, in here. The status is in process. And now our training process is completed. Let's see the details. It took about 123, which is like 2 minutes. Yes, we have our training image in here. As you might notice, this is the same as the training image. The path, the registry path is same. So yeah. We have used ML M4X large. We have one instance. Yes, in here you can see we have used ML M4X large, and we have used one instance. So that's that. We have also our S3 output path in here. The trained model is outputted in this S3 output. So any more information maybe? We have a S3 artifact in here. Let's see. Maybe we can download the model in here, I guess. Well, we don't have permission to see the details in buckets, so yeah. And after that, we have successfully trained our model using elastic containers. So let's host our model. So we will now deploy our model. Up to this point, we have also seen in the previous labs module 3, I guess we have trained our model in module 3. So up to this point, we have already done these steps. So now we will deploy our model. Now that you have trained the model, you can host it using Amazon SageMaker hosting services. The first step is to deploy the model. Because you have a model, XGB model, you can use the deploy method. For this step, you will use single ml mx4 x large instance. So since we have the XGB model in here, as you can see, so this model is, let me see, yeah, this is our XGB model. Actually, we have already specified before, so we can directly deploy our model using the instance count as 1, and we will use ml m4 x large. So let's run it. Now we have constructing our endpoint and model. We are now deploying it, so it may take some time. Let's see in here from the AWS console. We have now completed the training, so we will inference our model. So let's see if we have any endpoint in here. Yes, it's now in constructing status. So let me pause the video again. So our endpoint is now in service. Let's see the details. So we have ARN here. Also we have the URL. So we can use an API to request a prediction from our model. So model container logs in here. And yeah, CloudWatch. In CloudWatch we can see them. So I guess yeah, well, we don't have permissions to view the logs, so yeah, well, that's why we cannot see the CPU utilization and memory utilization, disk utilization, GPU, memory. Yeah, that's why we cannot see them, I guess. And inference, we have also in endpoint configurations, we have an endpoint configuration in here constructed automatically. So maybe I don't have permission to see the details, but well, let's continue then. We have successfully deployed our model right now. So endpoint configurations in here. We have also our endpoints in here. So let's perform some predictions from our endpoint. Yeah. Now that you have deployed model, you will run some predictions. First, review the test data and refamiliarize yourself with it. Let's see our test data. We have 31 instances with 7 attributes. The first 7 instances, first 5 instances are these. As you can see, these are the first 5 instances. Yes. You don't need to include the target value. This predictor can take data in the comma separated values CSV format, so you can thus get the first row without the class column by using the following code. So we will get the using the iloc rows and columns. To get only the first row, use this one. If you want to get row 2, you can use this one. To get all columns except the first column, use this one. So this means we are getting all columns starting from the first column, the column indexed as 1. Well, not the first column, but the index as 1, which means it's the second column in here. It will get these, and this will get give us the first row, I guess. Yes. So our row is this one, and we need to, let's show our row like so. So this is the first row without the class identified. So our model will predict the class. You can convert this comma separated values CSV file. Yeah, we can convert it into CSV file and store it in a string buffer. So batch CSV buffer, we get a buffer in here. So we will put our row into this buffer without headers and indexes. Our test row is now this one, I guess. Yes. So let's see the test row in here. So yeah, as you can see, we have comma separated values in here. Now you can use the data to perform a prediction. So yeah, let's predict our values. As you can see, it outputted 0.9. So this means that this shall be class 1, as you can see. So yeah, this is prediction isn't 0 or 1. Instead we get a probability score that we can apply some conditional logic to the probability score to determine if the answer should be presented as 0 or 1. You will work with this process when you do batch predictions. Yes, let's see the compare. Yes, I have already compared the result. As you can see, this shall be class 1 and our model successfully classified it as 1. So the challenge task: update the previous code to send the second row of the dataset. Are those predictions correct? Try this task with a few other columns. Yes, let's also send the second row using this. Also predict that. So let's run this. So as you can see, this is the second row. Oh, sorry. This is the second row in here. So let's also run this. As you can see, we have converted into CSV. Let's predict that as well. As you can see, it says it has 0.7 probability. So this one is predicted it wrong, I might say. So because since this is the 0.7, it says the class 0, so it says that it has a higher probability to be a class 1, but well, it's actually class 0. So let's also delete our endpoint in here. Let's see. As you can see, we have deleted our endpoint configuration, and it might take some time for this endpoint to be deleted. Yes, let's refresh our page. As you can see, our endpoint is now deleted. So we will perform a batch transform. So as in here, well, it can be tedious to send these rows one at a time. You could write a function to submit these values in a batch, but SageMaker already has a batch capability. You will examine that feature next. However, before you do, you will terminate the model. So yeah, we have already terminated our model. So performing batch transform. When you are in the training, testing, feature engineering cycle, you want to test your holdout or test sets against the model. You can then use these results to calculate metrics. You could deploy an endpoint as you did earlier, but then you must remember to delete the endpoint. However, there is a more efficient way. You can use the transformer method of the model to get transformer object. You can then use the transformer method of this object to perform a prediction on the entire test dataset. SageMaker will spin up an instance with the model, perform a prediction on all the input values, write those values to Amazon Simple Storage S3. So finally terminate the instance. So let's start by turning our data into CSV file that the transform object can take as input. This time you will use iLog to get all the rows and all columns except the first column. So yes, this way we are getting all rows and all columns except the first column. So let's see. And as you can see, we have all rows and columns except the first column. So next we will write our data into a CSV file. And we have uploaded it into our S3. Last, before you perform a transform, configure your transformer with the input file, output location and instance type. So we have our output location in here, and we have input. Also we have XGB transformer object constructed by using the transformer XGB model.transformer. So our instance count is 1. We are using ML M4X and we will use multi-record strategy, I guess. So assemble with line, so our values will be assembled with line by line, I guess. So our transformer will then transform our data, so we will predicting, I guess. So we will wait until it's finished. Let's run it. So let me see if we have any inference batch transform jobs in here. Yes, and it is now running. So we will continue after it is finished. So we have now completed our batch transform. Let's see the details. So in here it says it take about 2 minutes, but well, actually it is 6 minutes. I don't know why that says 2 minutes, but well, we have our model in here. We have instance type and instance count. So S3 URI we have, and input data configuration, output data configuration. Yes, in lab 3 batch in CSV, and we have batch out. So let's see the batch out file in here. After the transform completes, you can download the results from Amazon S3 and compare them with the input. First, let's download the output from Amazon S3 and load it into Pandas data frame. Yes, let's load it. As you can see, we have our predictions in here. So and we have used the test set to predict our models. Yes, yeah, and we will use the binary convert function to specify a threshold. If the values in here are greater than 0.65, we shall be classifying it as 1, the first class, and if it's less than or equal to 6.65, we will classify as 0. So then let's apply this binary convert function into our target. Yes, let's do that. As you can see, we have converted these into binaries, and some of them are, for example, this one is mispredicted. So for example, in the 1, 2, 3, 4, 5, oh yeah, the indexing is starting from 0, so 0, 1, 2, 3, 4, 5, 6, 7, 8. So this one is also wrong. As you can see, it shall be 0. Note the threshold in the binary convert function is set to 6.65. Challenge task experiments changing the value of threshold. Does it impact results? So let's change it into, for example, 55. Yeah, let's say C55, for example. And for that, well, in order to capture this, for example, it's really hard. You need to use a really high amount. So let's, instead of listing the first 10 of the records, since we have 31 of them, let's see, list all of them. Let's run it. Well, as you can see, for example, maybe in here, right? If we have a threshold of 65, well, that's not a good example, maybe, but for example, maybe this one. Let's see if it changes. The index 18. Yeah, this was on 65. As you can see, it is predicted as 0. Whereas if I set the threshold to 55, it would be classified as 1. So that's the difference. Yes, congratulations. You have completed this lab, and you can now end the lab by following the lab guide instructions. Let's end our lab as well. Okay. Thank you for listening to me.